Hey guys, in this video we shall look at the stresses in the material. Please don't forget to thumb up, subscribe and comment at the Smart Engineers. We shall look at the introduction, stress definition, type of stresses and numerical application of stresses. We all know that when an external force acts on a body, it tends to undergo deformation, and because of cohesion forces between the molecules, the body develops resistance to the deformation. Thus strength can be assessed. Hence, we can define strength of material as the resistance by which the material of a body opposes deformation. The stress can be associated with the strength from which the material is made of. There are assumptions made on a material subjected to external forces. These are the properties that a material should have for it to obey the Hooke's law. The material should be perfectly elastic, the material should be isotropic, and the material should be homogeneous. Let's also understand the notations like load, which is the combined effect of the external forces acting on a body. And examples are friction forces, applied forces, drag forces, spring forces, and many other forces. We can classify the forces as one, axial forces, which is the force acting on a body along the longitudinal axis, normal to its cross-section area. They can be divided into two: tension and compressive force. Number two, we have shear force. This force tends to slide or transform two parts of a body, causing shearing stress. As illustrated from the diagram, you can see that the two parts slides because of the shear force applied on it. Number three, we have the torsional force, and this force causes the twisting of a body above its longitudinal axis, resulting to torsional stress. As you can see that that body is twisted above its longitudinal axis. Number four, we have bending forces, and this force tends to bend a member, resulting to hogging and sagging in the member. We can experience bending stresses as compressive and tensile at the top and the bottom, respectively. What is stress then? Stress is the force of resistance per unit area offered by a body against deformation, or we can define as the ratio of applied force to the cross-section area of the body. Please note that the stress is the resistance to the applied force, and it has a load effect. So in order to define stress quantitatively, the force must be defined, and in addition, the configuration of the area in question must be defined. The following information is required: magnitude of force, direction of force, and the plane in which the area lies. So we can notice that the force is a vector quantity, and since it is a vector quantity, the magnitude of force, the direction of force, and the plane in which the area lies either x-axis or y-axis must be defined. So from the definition we can define stress as stress is equal to force applied over cross-sectional area. That is sigma is equal to P over A, or tau is equal to P over A. And the units may be newtons per square meter, or pascals, or kilonewtons per square millimeters, so forth and so forth. What are types of stresses? There are three types of stresses: simple stresses, indirect stresses, and combined stresses. Under simple stresses, we have shear stress and normal stress. The normal stress can be further divided into tensile stress, compressive stress. Indirect stress is divided into torsional and bending stresses. Combined stress is the summation of bending stress and normal stress. So we must understand or have the insight of what the direct stress is. So it is the normal stress in which the force direction lies parallel to the longitudinal axis of the member. They are classified as tensile and compressive stresses. So tensile is the stress induced in a body when subjected to two equal and opposite pulls, and it increases the length and reduces the cross-sectional dimensions, that is breadth and depth. Compressive stress is the stress induced in the body when subjected to two equal and opposite push, and it results to decrease in length and increase in the cross-sectional dimensions. Shear stress is the intensity or force applied per unit area, acting tangentially to the section. So numerically we can apply the formula of stress. It reads: a hollow steel tube with an inside diameter of 100 millimeters must carry a tensile load of 400 kilonewtons. Determine the outside diameter of the tube if the stress is limited to 120 meganewton per square meter. Solution: you're given applied force as 400 kilonewtons. That is an equivalent of 400,000 newtons. Sigma, which is the stress, as 120 megapascals. That is 120 times 10 power 6 newton per square meter. Then the area shall be the area of external area due to external diameter minus area due to internal diameter, because it is a hollow steel tube. This implies a quarter pi d square minus a quarter pi d square. The first d is for the external diameter, the second d is for internal diameter, which is 100 millimeters. Thus, we know that the stress is applied force over cross-sectional area. Therefore, we can say that the force applied is equal to the stress times the cross-sectional area. As we can see, it is 400,000 newtons is equal to 120 times bracket a quarter pi d square minus 10,000. You close the bracket. Therefore, 400,000 Newton is equal to 30 pi d square minus 300,000 pi. Then d square is equal to 400,000 plus 300,000 pi over 30 pi. D is equal to 119.35 millimeters. Hence, our external diameter is 119.35 millimeters. You can also be given other parameters to determine the unknown parameters. For example, you're given the stress and the area, and you're told to determine the force applied. So you may find the solution. You may find the solution to the problem 2 and 3 on the slides. I hope you've enjoyed. Thanks. See you in the next presentation.